DEMODULATIONS. Modems frequency modulation. Often band modulation refers that is to dictated provides a process by a number that physical moves of advantages the channel messer, e.g. mentioned signal voice band into in chapter telephone a specific one, including ease of RF transmission and frequency division multiplexing. Modulations can be analog or digital. Though traditional communication systems such as AM, FM radios and NTSC television signals are based on analog modulations, more recent systems such as 2G and 3G, cell phones, HDTV, and DSL are all digital. In this chapter and the next, we will focus on the classic analog modulations, amplitude modulation and angle modulation. Before we begin our discussion of different analog modulations, it is important to distinguish between communication systems that do not use modulation, baseband communications, and systems that use modulation, carrier communications. 4. 1. Baseband versus carrier. Communications. The term baseband is used to designate the frequency band of the original message signal. From the source or the input transducer, see Fig. 1.2. In telephony, the baseband is the audio band of voice signals, of 0 to 3.5 kHz. In NTSC television, the video baseband is the video band occupying 0 to 4.3 MHz. For digital data or pulse code modulation (PCM), that uses bipolar signaling at a rate of R beat pulses per second, the baseband is approximately 0 to RBHZ. Baseband communications. In baseband communication, message signals are redirectly transmitted without any modification. Because most baseband signals such as audio and video contain significant low frequency content, they cannot be effectively transmitted over radio wireless links. Instead, dedicated user channels such as twisted pairs of copper wires and coaxial cables are assigned to each user for long-distance communications. Because baseband signals have overlapping bands, they would interfere severely if sharing a common channel. Thus, baseband communications leave much of the channel spectrum unused. By modulating several baseband signals and shifting their spectra to non-overlapping bands. Many users can share one channel by utilizing 1404. 1 Baseband versus Carrier Communications 141. Most OF the available bandwidth through frequency division multiplexing, FDM. Long haul communication over a radio link also requires modulation to shift the signal spectrum to higher frequencies in order to enable efficient power radiation using antennas of reasonable dimensions. Yet another use of modulation is to exchange transmission bandwidth for better performance against interferences. Carrier modulations. Communication that uses modulation to shift the frequency spectrum of a signal is known as carrier communication. In terms of analog modulation, one of the basic parameters, amplitude, frequency, or phase, of a sinusoidal carrier of high frequency JCHZ, or W equals to NF radian per second, is varied linearly with the baseband signal MT. This results in amplitude modulation, AM, frequency modulation, FM, or phase modulation, PM, respectively. Amplitude modulation is linear, while the latter two types of carrier modulation are similar and non-linear, often known collectively as angle modulation. A comment about pulse-modulated signals. Pulse amplitude modulation, PAM, pulse width modulation, PWM, pulse position modulation, PPM, pulse code modulation, PCM, and delta modulation, DM, is in order here. Despite the term modulation, these signals are baseband digital signals. Modulation is used here, not in the sense of frequency or band shifting. Rather, in these cases it is in fact describing digital pulse coding schemes used to represent the original analog signals. In other words, the analog message signal is modulating parameters of a digital pulse train. These signals can still modulate a carrier in order to shift their spectra. Amplitude modulations and angle modulations we denote as MT, the source message signal that is to be transmitted by the sender to its receivers. Its Fourier transform is denoted as MF. To move the frequency response of MT to a new frequency band centered ATFCHZ, we begin by noting that the Fourier transform has already revealed a very strong property known as the frequency shifting property to achieve this goal. In other words, all we need to do is to multiply mt by a sinusoid of frequency Jc, such that S1 t equals mt cos 2 nfct. This immediately achieves the basic aim of modulation by moving the signal frequency content to be centered at plus or minus Jc via 1. S1 f equals 2m f. This simple multiplication is in fact allowing changes in the amplitude of the sinusoid S1 t to be proportional to the message signal. This method is indeed a very valuable modulation, known as amplitude modulation. More broadly, consider a sinusoidal signal St equals at t cos wet plus cent t. There are three variables in a sinusoid: amplitude, instantaneous, frequency, and phase. Indeed, the message signal can be used to modulate any one of these three parameters to allow St to carry the information from the transmitter to the receiver. Amplitude At linearly varies with mt. Frequency linearly varies with mt. Phase cent t linearly varies with mt. Amplitude modulation. Frequency modulation. Phase modulation 142, amplitude modulations and DEMODULATIONS. These are known, respectively, as amplitude modulation, frequency modulation, and phase modulation. In this chapter, we describe various forms of amplitude modulation in practical communication systems. Amplitude modulations are linear, and their analysis in the time and frequency domains is simpler. In Chapter 5, we will separately discuss nonlinear angle modulations, the interchangeable use often W. In Chapter 3, we noted the equivalence of frequency response denoted by frequency f with angular frequency W. Each of these two notations has its own advantages and disadvantages. After the examples and problems of Chapter 3, readers should be familiar and comfortable with the use of either notation. Thus, from this point on, we will use the two different notations interchangeably, selecting one or the other on the basis of notational or graphical simplicity. Click play button to listen to this text. You may edit this